we go. And for anyone, so I usually list all my video recording as private, but this semester I'm gonna list it as unlisted. Okay, if anyone is interested to kind of view it at the same time, or you have a need to get access to the stream, kind of live, we can do it this way. So I can go to my studio and then go to videos and then go to live and then go to the live stream. So here is the URL. Does anyone want access, here, to the live stream, or you guys are kind of, you want that? Okay. So you can either hand copy this, or I can send it as a notification or announcement. So let me see if I can do this. So I can copy link location and then go to the class and then send it as an announcement. There we go. Okay, so, is it not working? Oh. All right. So this does get sent to everybody. So if you do not need the link to the live stream, you can just kind of ignore that. If you do want it, you can now click on the announcement and the link should work. There's a lag, okay? So the problem is there's a lag of about 19 seconds or about 20 seconds. So what you will be watching through the live stream is going to be behind by about 20 seconds, okay? All right, so now we can go ahead and get started with the syllabus. I also changed the format of the syllabus a little bit. So instead of being an HTML page, it is now a PDF. And I am going to open the PDF in a program called Zernal. If you don't know what Zernal is, it's really a great program. It's open source, it is free, and it also allows people with a tablet, with a stylus, to do freehand drawing. So I'll be using this also in this class. Whenever I need to use the whiteboard, I won't be using the whiteboard. Instead, I'll be using this program. So everything that I hand draw during the class is also going to be recorded. Okay, so we'll go ahead and get started here. So you can see the table of contents of the syllabus is one page all on its own. So do you guys know of any professor with a longer syllabus? No? Yes? Maybe? Yeah? Which class?
The math class that I took with Rudick and Arrow, because he goes through like every section of every chapter.
In the syllabus?
Yeah.
Wow. Okay. All right, so this class is fairly easy. We don't have a lab component. It's a full semester class, so keep in mind, when is the last day to drop the class without a W, and when to drop the class with a W notation. It's a Monday, Wednesday class. The lecture time is from noon to 1:20. Okay, so I do have to include this information, because if I don't include it, someone is gonna get on my back and tell me to include it. The objectives, is listed here. I'm not going to go over the objectives, but at the end of the semester, we can kind of go back and compare to see whether we learned all of these things. It's going to be a very packed class, okay, because there's a lot of material in this class. Compared to CISP440, the problem with this class is a lot of these topics are not exactly connected, so it's kind of like a hodgepodge of a lot of different stuff. Section 2 is really just me being defiant of not using Canvas to maintain the syllabus, because I think this is a better tool for me to maintain the syllabus. All right, so now we talk about me. My name is Tack, so you can call me Tack, you can call me Dr. Tack, you can call me Professor Tack. Those are all good. My last name is Aoyong. Okay, it's a little bit difficult to pronounce, and even that does not resemble the actual last name, which is in Cantonese. So just call me Tech. It's all good. Any questions? No questions? All right. Phone number is 916-484-8250. I am usually not in my cubicle to answer the phone, but if you do leave a message, it's going to be emailed to me as an MP3, so it's kind of cool that way. For most things, I would prefer that you send email to this particular address. I found that I also have a Gmail account. So the apps.losrios.edu account, I have one over there as well. But I would prefer, classes, to send email to this particular address, so I have one place to check for student email. Office hours is kind of awkward this semester. On Mondays and Wednesdays, including today, it is 9:30 to 10:30, and it's not in my office. It is over at the Design Hub. Okay, so if you don't know where the Design Hub is, there are a few people here who know, and they can help you find the Design Hub. It is in Tech Ed 311, which is kind of not right away, but it is to the north of the Child Care Center. So if you hear, young children screaming, you're close. On Tuesdays and Thursdays, my office hours are from 4:30 to 5:30, which is right before my assembly language programming class. And then on Friday, it's from 8 to 9, so it's kind of all over the place a little bit this semester. If none of these time slots work for you, okay, you can send me an email, and then we can work out a time to meet. We just have to find the time when I and you, both have time to do it. Okay. Are there any questions about Section 4? Okay. Section 5 is about how class material is delivered. It's basically just a typical lecture class. Other than the fact that I record all my lectures, it's pretty much standard. Any questions about that? No questions. All right. Section 6 is about regular effective contact, which is a big topic in online classes. Okay. Is there really a live person on the other side of your online class? But this is not an online class, right? Unless we are in the matrix and we don't know it. Then everything is online. Yes? Okay. But since nobody has taken the red pill, we don't know whether we are in the digital world or not. So we'll just say that this is not an online class. Okay? Can we agree on that? Okay, at least for the duration of this semester. If you want to take the red pill, do it after the semester. I can think of all kinds of jokes with NyQuil, because they also have the blue and the red, depending on whether it's Dayquil or NyQuil. So basically, if you want to contact me, the best way is to make it to my office hours. Okay, I do have one office hour per day. If you go to the Design Hub and you find me at the Design Hub, okay, I'm also at the Design Hub every day, okay, about 2 hours each day. You can talk to me, okay? You can talk to me at the Design Hub about class stuff if you can find me over there. If you send me an email, okay, which is not really the best way to interact with me, but give me about 24 hours, up to 24 hours to reply, okay? But the best way to contact me is just to find me, and talk to me in person. Any questions about, how to contact me? Okay, all right, moving on. So the behavior policy is fairly kind of common sense stuff. In class, I would rather not to have disruptive or distracting behavior. Usually, I just get, the minor chatting, between people. And most of the time, it's not even, malicious, or it's not even chit-chatting. It's really just one person not getting what I just said, and then ask the next person, what did Tech just say? Well, guess what? When that person is trying to answer the question of the first person, the second person will also miss what I am saying at that time. And then the second person will have to ask the third person what I said when the second person was trying to answer the first person. Then the third person would not be paying attention to me, right? And then miss what I said. And then that person will now have to ask the fourth person. You can see how this kind of daisy chains and become a linked list, right? So to avoid that, it's best to just raise your hand and ask me. Okay, if you don't get what I just said, if you need some more time to write it down, we can just kind of take a break. Okay, I can give you more time to write down something, or I can answer your question. Is that okay? All right. Let's see, next one. So we are increasing in terms of intensity. 7.2 has to do with behaviors that can cause fear, intimidation, or discomfort. So those are definitely not good. And if I know about it, I will tell people to stop it. Okay, but if I don't know about it, you guys will have to let me know. The third one, is even worse. Okay, violent or other types of dangerous or endangering behaviors. That's when I start to call campus police. Is that good? All right. Do you guys have that app installed? I think it's what is the name of that one? I kept.
Brave Guardian, it's on the wall over there.
Yeah, Brave Guardian. So it's a good app to install. Sometimes you get your false alarms, but for the most part, it will keep you informed if there's something going on any one of the campuses. Is that good? How many people have it installed? I got it installed. No, you don't?
No, never, but I've never
They still text you though, because if you give them a text number, you will still get texted about those messages. First day of class or orientation, you're here already, so we are all good. But if someone is missing, I'm going to take roll, okay, and those people will be automatically dropped. Now, doesn't mean that they cannot take this class in this semester. They just have to be added to the class again. Okay, so since I reminded myself, I'm going to pass this along. There you go. If you need accommodations, okay, the DSPS is the place to go because I don't understand, all of the different accommodations, so they can arrange all of that stuff. So the DSPS office has a phone number 484-8382, or you can go to the DSPS center and talk to those people. Are there any questions about section 9? Okay, no questions. All right. Excessive absence, basically after all the math is done, excessive absence starts on the third unexcused absence. So everybody in this class has 2 unexcused absences that are okay. The third one is not. Is that okay? So that's all based on roll taking too. So if I forget to take roll one day and somebody is missing, it doesn't count as unexcused absence. Okay, so it's all based on when I take roll. Now, if somebody forget about the exam, okay, then I would notice, because when I grade the exams, I would notice that hey, this person did not turn in anything. So I would also use that as a means to take roll. It usually doesn't happen. Okay, when people start to miss exams, I think something else is going on. So do we have any questions about excessive absence? No question. Okay, so up to 2 unexcused absences is okay. The third one is not. So absences that are excused include any type of summon by the government, and also illness or sickness of the student. So in past semesters, I have had issues. I know people are sick. They call me or they email me and they say that they're sick, but I still want some kind of proof. Okay, I would still want something on paper. And some people do not have insurance, or they do not want to go see the doctor, or it's not big enough to go see a doctor. So starting this semester, I will also use pharmacy receipts as quote unquote a proof of just being sick and not be able to get to class. Is that okay? All right. So that Dayquil or NyQuil prescription, may come in handy. Getting back to the red pill and the blue pill thing. So everything else is technically unexcused, okay? It doesn't mean that, if somebody tells me, oh, I got an interview next week and I already have 2 unexcused absences, it's not like, I'm gonna drop that person right away, okay? So I will try to be reasonable, but when it becomes a habit, like every week that person has an interview, then I will start to use this policy and go like, well, I think the first or second one is okay, but when you have an interview every single week, then we start to have a problem. Okay? There's no late policy for this class. Homework assignments have to be turned in on time to be counted. So anything that is not submitted on time, on Canvas, is not going to be counted. You typically have at least 1 week to work on the homework assignments. So my advice is to start early and try to get it done, before, because the reason why I allow 1 week is so that we have one more class meeting to talk about it. Okay? Section 13 talks about academic dishonesty, but you can also look at it from the perspective of integrity. So what that means is the grade that a person is receiving is going to reflect the academic performance of that person and that person alone. So that's kind of the bottom line. And all the rules have to be followed, okay? And I can already tell you how the exams are administered in this class. They're all on paper, no electronics other than a calculator. But it's open book and open notes. In fact, you can bring as much stuff as you want as long as it is on paper. Okay? So, any questions about that particular policy? No questions? Yep.
Do we have a book?
We do not have a book, but if you find a book that you think is useful, you can bring that. Mm-hmm. If you know past students, okay, who have my past exams, okay, you can bring those as well. I'm not sure how helpful that's going to be, but it is allowed. You can even go through the videos, okay? If there's one particular video frame, okay, that has a picture or drawing that you think, okay, this is exactly what I want, okay? You can just freeze the frame, okay? Clip it out, okay, and print it out. As long as it is on paper, you can bring it. Do we have any questions about the policy? No? Okay. So in case I accuse someone, of cheating, and that person says, no, I did not, okay, I typically will listen to people, okay, as long as they can explain something to me and it sounds reasonable to me, I will listen to it, okay? But there are occasions where I kind of stick to my conclusion, and if the student, thinks, okay, but I really did not do anything wrong, this is the document for those people to read, the Guide to Student Rights and Responsibilities, because it will outline the grievance process. How do you complain about not being treated fairly, and so on and so forth. Okay, it's a good document to read anyway, so I do strongly recommend everybody to read that. Classroom behavior expectation. We talked about chatting already. Interrupting, if you have a question, raise your hand first. I will try to address your question as soon as possible. Okay. Mobile devices, just turn off the ringer during the class so that it doesn't distract other people. So, any questions about these kind of typical common sense stuff? No questions? So this classroom does have a sign that says no phone, food, or drinks. I can allow drinking water, okay? Just plain water is fine, okay? But if it's sugary or if it is coffee or tea, something that can stain carpet, try not to, not try, but do not drink it during class, okay? If it's just drinking water, it's okay. So I got to tell you something about drinking water or bottled water. I have this kind of little gadget thing that can test the quality of water, okay? And I have a filter at home for drinking water. So it has a unit of one. I think it's ppm in terms of dissolvable solid or something like that, okay? So it's one, which is pretty good. I tested tap water. I think it's about 20. No, tap water was, yeah, tap water was about 20. Bottled water was 50 something. I also run a dehumidifier at home. Okay, you're basically removing moisture because moisture encourages the growth of mold. So I try to maintain the humidity to somewhere below 50%. But because it's a dehumidifier, the humidity has to go somewhere, right? So it condenses in the form of water. So you might think that's kind of yucky, right? I mean, this is just, moisture that is condensed into water and it's got collected into a little bucket. That actually has the same number as bottled water. In other words, these bottled water companies could have been just using condensation from air conditioners, put it into a bottle, put a cap on it, and then sell it to you as bottled water. So next time you buy bottled water, just remember this. All right, how to attend lectures. Okay, if you're in this class, it usually means you have taken a lot of classes already. So you know how to attend classes already. But because I do record my lectures, so that means as long as you can confirm that things are getting recorded, you don't have to copy everything onto your piece of paper during class, which also means you can instead pay attention to what I'm talking about and see if you understand the concept. And if you don't, ask questions so that the class can become more interactive instead of me just kind of projecting some notes and you busy, kind of writing everything down. Make sure that you're understanding the concept. Are we good with that? Okay. The second thing is, if I start to talk about a new topic, you might want to jot down the time on your note because that will help you locate that video and that portion of the video quickly. So let's just say that I'm starting to talk about Dijkstra's algorithm and the time is 12:25. So if you write it down on a piece of paper and you maintain that, that means, if you want to ever go back to that lecture, to talk about, Dijkstra's algorithm, you don't have to start from the beginning. You know what date it is, and you know that it's about 25 minutes into the lecture. So that will help you to locate topics quickly, by when you go back to the video recording. Does that make sense? Okay. So you do want to kind of check with me occasionally to make sure that it is being recorded. So if you tell me or if you ask me, then I will go to OBS, okay, to make sure that it is being streamed. Okay, the green bar here means it is streaming. The audio bar needs to be fluctuating because sometimes I forget to turn on the mic or it runs out of battery. But as long as we have the audio and it is streaming, the computer can lock up right now and we'll still have the majority of the lecture uploaded already because it's being streamed to YouTube in real time. So the worst case is we might lose 19 seconds, okay, because it takes time for YouTube to encode stuff, so it might be behind by 19 seconds. Are we good so far? So I'm fairly sure that we can kind of record most of the lectures, but I do need you guys to help remind me to check occasionally, especially at the beginning of the class. All right. So section 17 is really long. I'm not going to read the entire thing, but the gist of section 17 is, do we know whether we understand a concept or not? Okay, that's one of the things when I was in college I was able to do was I would be taking a class, trying to understand the concept, but when I don't really fully understand the concept, I know that I'm not fully understanding a concept. and then I'll spend time to try to understand it. So I cannot explain, how, I can, kind of self-detect that I'm not understanding a concept, but it's really important, okay? So I can only emphasize the importance of that, but I cannot teach other people, how that works. Does anyone in this class kind of want to share your experience with this sort of thing? How many people kind of get this gnawing feeling? Okay, you go to a class, it can be physics, can be calculus, the professor is talking about a particular concept. You understand every single word, okay? You look at the equation, you can understand all the symbols, but you're not getting it. You kind of get that kind of feeling. It's like, I'm not fully getting it. I can understand all the symbols. I can understand, the sentence, but I'm not getting it. Okay, so that's really important. If you get that sense, it is good to ask me for clarification. The form of question you can be asking can also be an example. Okay, you can say, okay, see if I understand this correctly. If we have a case like this is the example, blah 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 blah. So is this reflexive, or is this symmetric, and so on and so forth? Those are the concepts that we'll be encountering in this semester. Okay, so you can use examples to help me understand whether you're getting the concept or not. Is that okay? All right. So this is a long section, because I'm trying to explain to people what understanding really is. One thing it is definitely not is memorization. Okay, there are some people confusing memorization as understanding. If I can recall a sentence, if I can recall an equation, I understand it. That is not the case. Understanding has to do with, can you associate that concept and link it with things that you already understand? Okay? So it's not about this thing, this entry on its own and whether you know how to recall that or not. It has to do with how that links to other things that you have already understood. Now, the reason why this is important has to do with tests, okay, the exams. So before I talk about the exams, let me just share with you the letter grade equivalence first. So I'm jumping around a little bit. So I'm just jumping to here. So anyone at the end of the semester, getting at least 87.5% of all the points possible is going to get an A. So you look at this and go like, a normal class is what, 90%? So it's pretty close. A B is from 62.5% to 87.5%. So that's already kind of strange because, a normal class is going to be what, from 80 to 90%? A C is, in this class, is 37.5% to 62.5%. A D is 12.5% to 37.5%. And an F is, below 12.5%. So now the question is, how do I come up with this crazy scale? If you look at the center of a C, it is 50%, because 2.0 as a GPA is right in the middle of 4. Okay, so I'm just scaling everything based on A, B, C, D, F, the letter grades themselves, and then allowing 12.5% in either direction, so that we have a range of percentage around each letter grade. The reason why I can do this in this class is when I grade everything in this class, I evaluate using the A, B, C, D, F standard. Okay, in other words, I would look at an answer to a test or an assignment and ask, is this an excellent answer? Is this a good answer? Is this a satisfactory answer? Is this a low pass answer, or is it failing? But because I grade everything using the A, B, C, D, F standard, that means the average of everything that I grade is just using the same scale. I have some past students in this class, so they can share with the rest of the class whether grades in my classes are easier than other classes or not. I would not be a good person to ask about that. So what do you think?
It's scaled that way for a reason.
Yep. There's no fluff.
No.
Yep. So there's no fluff to fill it up the 60%. That's basically the bottom line. So now the question is, what do I ask in an exam? They are all problem-solving type of questions. There are no recall, no, okay, what is the definition of this thing? Okay, you just flip through your pages and you just copy. There are no such questions in my exams. They're all problem-solving type of questions. And there are many of those questions where the way to solve the problem, we may not have seen it in the class, and that's intentional. Because I'm testing whether you understand the concepts and be able to apply the concepts that you have learned to problem solve something that you may not have seen in class. Is that okay? Does everybody understand what I'm saying? So, okay, I can give you an example in Legos. So in class, I will show you all the different Lego pieces, okay? The boring type, the ones that articulate, the ones that have motors, the gears, the pneumatic ones. Have you guys seen the pneumatic pieces in Legos? Kind of like, they're pistons, and you can compress air, and then there's tiny little air hoses, and then when you compress one piston, and then whatever it connects to would extend. You guys, have you seen those? No? Okay, they're really cool. So in class, I will explain each one individually. Okay, I'll even show you examples. Okay, this is how you make a tricycle. Okay, this is how you make a pump. Okay, and so on. But in the exam, I'm not going to ask you, how do we make a tricycle? In the exam, I'll ask you, okay, how do we make a Segway? Okay, it's related to a tricycle. It's a tricycle minus one wheel, right? But how do you make it stable? How does it not fall, right? So then I will probably have to talk about balancing. How do you move the vehicle around to shift its center of gravity? So I would talk about that too if I were to ask you about a Segway problem. Okay. But the idea is I will introduce all the building blocks. I will introduce examples of how the building blocks can connect. But in the exam, you will probably encounter something where, okay, it is all the same pieces, but how do we connect these pieces to get that done? That you have to think on your feet during the exam. Is that okay? Kind of resembling a work environment. Okay, because in a work environment, you don't get to solve problems that are already solved. Why would your boss pay you to solve a problem that is already solved? It doesn't happen. Okay, so most of the time you'll be encountering things that are slightly new, using the building blocks that you already know. So that's kind of the test that I will be giving you in this semester. Are there any other questions? Yep.
Would it be like multiple choice or just
There won't be any multiple choice questions. So every question is open-ended, which means it will take a while to grade, for sure. Okay, it's just a matter of how long it's going to take me to grade the exams. Where's the row sheet? Okay, thank you. I just want to take a quick look at how many people are in this class. So we got all 39 people enrolled here, minus 1. And then 1, 2, 3, 4, 5, 6. So we got 8 people beyond the actual enrollment of this class. So I can add everybody to this class, so that's the good news. So if you're on wait list or even beyond the wait list, as long as your name is here and your student ID is here, I will send you an email with your permission number. Is that okay? But that also means this class has close to 50 people. So that's a lot of people in a single class. All right, so I'm almost done with the syllabus. Are there any questions? No questions. So moving on to things that will give you percentages. There's homework assignments. All the homework assignments add up to 20%, which is not a whole lot. There are 2 midterms. The first and the second exam, each one is 20% also. And then the final exam is 40% on its own. So are we okay with how the points are distributed? Okay, all right. So many of you have heard this already, but some people are new. This means if somebody did not turn in any homework assignment, got zeros in both the first and the second exam, and then aced the final exam, that person will still be passing this class with a C. That's the way it works, okay? Or alternatively, somebody can turn in every single homework assignment, okay, get all the points, or get all the 20 points. Ace the first exam, okay, early on in the semester, that's 40% already. And then that person only has to show up in class not to be dropped because of the excessive absence thing, and not to do a single thing in the second exam or the final exam. That 40% is going to give this person a letter grade of C. Now, do I encourage people to do it that way? No. If someone is getting perfect scores with homework assignments in the first exam, why not push it to get to a better grade, right? Get to a B, get to an A. But if someone decides, I'm not a B or A kind of person, I'm a C kind of person, well, feel free to do it that way, okay? I'm not judging people. Is that okay? All right. Cool. So in this class, remind me to give you ungraded assignments because, graded assignments just takes a lot of time to grade. But I can give you ungraded assignments. So I can give you problems they can solve like over the weekend, okay? And then the following week, I'll give you the solution. I'll explain my solution. So you can look at your solution, you can look at my solution on the projector, and you go like, my answer is different, okay? You can use class time, or you can use my office hour to ask questions. It's like, well, I came up with this answer, and it's different from your answer. Are both answers correct, or is one of them wrong? Okay? And if I see a wrong answer, usually I can pinpoint where the misunderstanding is, so that can be useful. Okay? So try to utilize my office hours. Yes?
What do you mean by remind you? Just raise our hand at the end of class?
Yeah, or at the end of the class, you can just come to me and go like, I would like to have, an exercise, with the concepts that we have just learned today. Yep. Yep. Let's see. Well, that's about it. This is the tentative schedule of topics, as I pulled it from the curriculum or the syllabus. I mean, not syllabus, but the curriculum. The order is off a little bit, so I would change the order. So the correct order is in Canvas. So are we good so far? Okay, all right. So that means we can actually get into the content of this class at this point, and it is 12:45-ish. Okay, so if you want to write down, 45 minutes into the recording is where the class actually starts. Okay. So we'll go ahead and get started. So the syllabus is the first link, in Canvas. People who are on the wait list, I will add you to Canvas right away and then give you the permission number next. So this way you have access to all the class material like right away. You don't have to wait a day to get to it. So the syllabus is right here. The final exam schedule is updated. So this one does reflect the correct final exam schedule. So we are going to have our final exam as scheduled, over there. So you just look up the start time of this class, which is 12, noon time. And then look up the correct date and also the correct time, for your final exam. When it's close to final exam, I will also remind you what day, what time, is the actual final exam. This link here is kind of cool. I like, MBTI or some kind of personality test. If you have not done a personality test ever before, you can try to do one and see if that describes you. Okay. In my case, it described me like almost 100%. It's kind of creepy, because I just did the test, look up the four-letter thing, go like, and I could not actually, I don't know myself, okay, very well. So I let somebody else read it, and that person goes like, "Yep, that's you." The reason why I encourage people to do a personality test is this way you know your strengths. Okay, because the personality test typically will give you a conclusion and summarize, based on your preferences, based on your personal preferences, where your strengths are. And it is helpful to understand that part. Okay, it will also help you understand how you communicate, and that is really helpful as well. Even in a class setting, it is helpful. So for those of you who want to know, I am an INTP. Okay, so you can write it down if you want to. Are you an INTP too? Okay, so INTPs, have certain characteristics, but communication between types can be very different. Okay, so you want to, if you do a personality test, if you do an MBTI or Myers-Briggs type indicator test, you will start to understand, your communication style, and because I'm an INTP, then you will start to understand my communication style as well. Sometimes, if I don't put an effort into it, it can go like this. Okay, somebody can talk to me and totally, miss the mark. Okay, but if I do, when we are aware of this difference, how we communicate based on personality types, that can really help to improve communication. Okay, so that's the reason why I put it up here. All right. So the syllabus stuff, this one you won't see because this is actually hidden. It's kind of obsolete stuff, so we can kind of not need that. This one talks about taking a classroom tag. You don't have to read it. It's based on personality type. So once you have taken the personality type test, you can read it. So that way you get a better understanding of stuff. So this is actually where the real stuff begins. Okay, Boolean operators. So we're gonna start with this one. And hopefully it is not a surprise to most people. So we'll start with things that we already know in C and C++, starting with what a conjunction is. Conjunction is really just a fancy word for and in C++ it is known as ampersand, not a single ampersand. How do we call a single ampersand? It's a bitwise and. Very good. Okay, so a logical and is double ampersand. So this is one way to represent, what and does. So if x is a 0, y is a 0, then 0 and 0 is a 0. So in this class, I would use 0 and false interchangeably. I would use 1 and true also interchangeably. Is that okay? All right. So this table tells you all the 4 possible combinations. We have 0 and 0. We have 1 and 0. Then we have 0 and 1. And then we have 1 and 1. But because x can only be 0 or 1, y can only be 0 or 1, there are only 4 possible ways to combine x and y. So this is one way to look at a truth table. Most truth tables do not look like this. This is more like a matrix to look up, the result of and. So are there any questions about this table or how to read that table? No questions? Okay. So the other way to look at x and y is kind of more concise, is kind of like this, where the vertical thing is each row. Okay, y. Okay, each row represents the case when y has a particular value. Each column is for x, and then you have still have the matrix here. So this is still reflecting what is 0 and 0. This is reflecting what is uh, 1 and 0, because the 1 applies to x, because x goes across, and then y goes vertically. So just a more concise way to look at conjunction. And these are the various ways we represent conjunction in terms of symbols. In C++, this is how we look at x and y, logical and y. This is the mathematical symbol, okay? It looks like a little TP. But in engineering, in electrical or computer engineering, a lot of times, people also kind of overload the multiplication operator to mean conjunction. Okay, so either we look at it as just x dot y, because we usually use a dot to represent multiplication, or sometimes there's no symbol between x, y. Okay, because in math we know that we just write x times y a lot of times as just xy without an operator in between. Is that okay? All right. All right, so the next one is disjunction, or basically a fancy word for or. Okay, so we kind of know what or is already. 0 or 0 is 0, 1 or 0 is 1, 0 or 1 is 1, 1 or 1 is 1. Okay, so it's just basically double bar in C++. So I can kind of skip the tables because I think we know that already. In terms of symbols, x double bar y is how we represent logical OR in C++. In mathematical symbols, it looks like a V, but it's not really uppercase V. But if you want to use the engineering symbols, OR is very often using plus. So you can look at the plus operator as overloaded in this case to mean disjunction in Boolean logic. Is that okay? All right. So it's nice to be able to write x and y as just xy, and then x or y as x plus y, because we don't need special symbols on the keyboard to type out Boolean expressions that way. Are we still doing okay so far with the symbols? Okay. The next one is negation, which is not. Okay. So in C++ or C++, and many other languages, we use an exclamation point to mean logical negation. In mathematical symbol, it is a kind of like a cliff symbol and an X. And then in electrical or computer engineering, it is usually using an overbar to mean the logical negation. So once again, just a whole bunch of symbols. These are alternatives to represent exactly the same thing. So in this class, despite I use xy to mean x and y, I use x plus y to mean x or y, but in this class, I'm going to use exclamation point x to mean not x, because that's easy to type. The overbar thing is really kind of nasty when it comes to typing it using just Notepad. Okay, but exclamation point, pretty easy. So do we have any questions about not, logical negation, disjunction, which is or, logical or conjunction, which is also known as logical and? Do we have any questions about those operators? No questions? Well, I have a question. Are they all needed? In order to express every single way to relate two Boolean values, do we need all of those? Yes. We can use NAND or NOR. Okay, we never talked about NOR in CISP440, but NAND is enough. Okay, so NAND, N-A-N-D, means negated and it literally is really just negated and. Okay, so I'll talk a little bit about this, but I'm not gonna go too far in this class. I do go over this in CISP440. So I just want you to know about it, but you don't have to know all the details about it. Okay? So x NAND y is basically defined to be the negation of x and y. That's it. Okay? So it's a very strange operator because we don't use NAND in normal language. Okay? No natural language that I know of has a natural word for NAND. So why do we do NAND? Because all of the other operators, logical negation, logical OR, and logical AND, can be done by some combination of NAND. So if you want to impress or piss off your other professors, okay, when you write your next program in C++ for 430, okay, you can just say, I'm going to define a new operator NAND, and then not use negation, logical AND, or logical OR. Everything is expressed using NAND. The point is, you can in fact do that, okay? If there's no other logical operator and there's just NAND, you can actually use NAND to define all of the other logical operators. Now, will your professor appreciate that? That's a whole different question, okay? I'm not going to answer that one. So Professor Hermele, Professor Fox, well, Professor Fox is not going to be bothered anymore. He's about to retire. Okay, this is his last semester. If you don't know already, this is his last semester teaching here. So you can turn in a homework assignment where everything is NAND. He's just going to look at it. Oh, okay, cool. You know. But this is kind of fun, okay? It's kind of interesting because we never thought of logical operators like this, okay? If you take CISP440 from me, you will know about, how the equivalency is done, okay? But in this class, I'm not going to get too much into it. Okay, well, maybe a little bit. All right, but we do have some other operators that we need to use in this class, and these operators are missing in C and C++. There's implication. Okay, the implication symbol is the double bar arrow thing. So x implies y is an expression. Okay, so how do we look at this table? This table says if x is false, okay, this is x, and y is false, x implies y, which is false implies false, is true. Okay? How about this one? This one says x is true, but y is false. True implies false is false. This one here says x is false, y is true. False implies true is true. This one here says x is true, y is true. True implies true is also true. Okay, that sounds awfully confusing. Okay, if this is the first time you get introduced into implication as its own operator, that sounds really, really confusing. Okay, so I can give you an example, and hopefully that will help clarify what that means when we say whether the implication itself is true or false. Okay, so we'll just go ahead and say P is just an abbreviation of the sky is orange. Okay, and then we'll say Q is really just the abbreviation of everyone fails CISP440 for this semester. Okay, so you look at P, as a statement. It can be true or false, right? You can look outside and go like, yeah, the sky is kind of orange, or the sky is not. And then you look at Q at the end of the semester, and it can either be true, everybody failed the class, or not. Okay, not everybody failed the class. Is that okay? So P has its own Boolean value. Q has its own Boolean value. Are we good so far? All right. So I ask everybody to pay me $10, okay? And then I will give you some words of wisdom, okay? So the word of wisdom or words of wisdom I'm giving you is P implies Q. and you pay $10 for this. You pay $10 for me to say, if the sky is orange, then everybody is going to fail CISP 440. Is that okay? So what you just pay for, that $10, bought you a Boolean expression. The Boolean expression is simply P implies Q. P is the abbreviation of the sky is orange, and then Q is the abbreviation of everybody fails CISP 440. So why do you care whether the implication is true or not? Because you want your refund. Okay? If what I told you is false, you want your refund at the end of the semester with interest. Makes sense, right? So now the question is, under what circumstances are you going to get your refund, and under what circumstances are you not going to get your refund? Does that make sense? Okay? So if what I told you for that $10 is true, you cannot get your refund because what I said is actually true. On the other hand, if what I told you is false, then at the end of the semester, I'm going to have to pay you back with interest. Is that okay? All right. So let's look at the 4 possible outcomes, okay? And if you want to, you can kind of at least once in the semester, okay? So that means, if at least one day you see an orange sky during the semester, that makes the statement P true, okay? So that makes it kind of easier to read, I think. Okay, so let's look at the 4 scenarios. So we look at P, we look at Q, we look at P implies Q, which is basically saying, tag is right. Okay? Okay, so we have false, 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 true, true, false, and then we have true, true. So those are the only 4 possible cases. Let's look at each one individually. So this row says, during the entire semester, nobody could observe the sky being orange. Okay, so P is false. Not on a single day the sky is orange. And then Q is also false because, we have at least half of the class passing with A and B's, and then the other half, getting C's and D's. So definitely, a lot of people pass this class. So Q is also false. So the question now is, how about the implication itself? It is true, okay? So the implication is true because I never said anything about what would happen if not on a single day the sky is orange. All I said was the sky being orange is a sufficient condition for everybody to fail this class that semester. I didn't say a single thing about what would happen if the sky was never orange during the entire semester. Is that okay? Let's look at the second case. The second case is saying the sky was never orange during the entire semester, but guess what? Everybody failed this class because nobody seemed to grasp this concept. Okay? But can you get your refund back? The answer is no, you cannot get your refund because what I said is still true because I never said anything about what would happen if the sky was never orange during the entire semester. All I said is the sky being orange is a sufficient condition for everyone to fail the class. I did not say it's a necessary condition. Okay, so that's the other way to look at implication. If P implies Q, we are basically saying P is a sufficient condition for Q. All right? What about this one? Okay? Let's just say that tomorrow, okay, the sky is orange, okay? But you know what? Everybody passed the class, at the end of the semester. So in addition to celebrating, yes, I passed the class, I survived one of tax classes, guess what? You get your $10 back with interest, because this conflicts with the statement that P, the sky is orange at least one day during the entire semester, then everybody's going to fail the class. It conflicts with that conclusion. Is that okay? So what that means is true implies false is false. The implication itself is false. I think the last one kind of goes without saying. You don't get your refund back because it is precisely what I said would happen. So are we doing okay so far with this? So the key to understand this whole thing is implication is just an operator. That's all it is. It is just an operator. It takes a Boolean value on the left-hand side, it takes a Boolean value on the right-hand side, and it gives you a Boolean value as the result. That's all it's doing. So from that perspective, it is really not that different from conjunction or disjunction. All it's doing is to say, give me two values, I'll give you the result. So are we doing okay so far with the concept of implication, but we are using it as an operator? Yep.
Do you call P the hypothesis and Q the conclusion?
I'm pretty sure there are names for that, but I cannot remember. I think one is... Okay, so we can look it up. You know, I can never remember the actual terms for each part of an implication. But if you look up parts of an implication, I believe, you know, the first link will get you the answer. Yeah, so one is called the antecedent. You know, P is called the before-cident. And then Q is called the consequent, which is after consequent. I'm trying to break up the words into its components. So is that okay? All right. So are we still doing okay so far with operators? Yes?
Can you go over why the second one evaluates to true?
The second one evaluates to true?
Yes.
Well, the first two are really the same in the same category. Because what I said, if P then Q, I never said anything about what about P is false. So that's the reason why in the first two cases fall into the same category, because I didn't say anything about what if the sky was never orange. So it can be anything and it would still not be inconsistent with what I said. Okay? So are we doing okay so far with implication? So for the most part, what you need to do, okay, if these examples are just adding to confusion, all you have to do is not to associate meanings and really just focus on the truth table. Okay, just look at the truth table. You will be given what is P and what is Q. Look up the truth table and find out what is the value of P implies Q. That's one way to deal with it if the word implication is causing issues. So are we good so far? Shall we move on? All right. So moving on, let me go find my notes here. So the next one is equivalence. Now equivalence can be defined using implication and conjunction. So X being equivalent to Y is basically saying exactly the same thing, but lengthier, of X implies Y and Y implies X. It is also known as X if and only if Y, because the if goes in both directions. Is that okay so far? Are we good? All right. So after we have introduced implications, is there a control structure in C++ that reminds you of implication? No, control structure. So control structures are like conditional statements, loops, switches, and stuff like that. So which one kind of resembles implication? Hmm? If, exactly. So let's take a look at if and how we use it in a programming sense. And this is another thing we can do as a send away gift to Professor Fox. So when we say if P, okay, we perform this statement, okay, we'll call this statement 1. And then else, okay, we perform statement 2. Well, actually, this one is too well spelled out. We'll do it this way, okay? So it's a simple conditional statement, doesn't spell out the else case. All it says is P, we perform statement 1, okay? So what if P is false? Based on your understanding of C++, what's going to happen? Statement 1 will not happen. Okay, very good. Okay, so that's the actual behavior of a conditional statement that has no else. Is if the condition of the conditional statement is false, we do not perform the then branch. Okay? Does it say if and only if? No, it says if. If this were if and only if, it would have two F's. IFF is the abbreviation of if and only if. Okay, so what is the difference? If this is if and only if P, then we perform statement 1, then the behavior that we observe in C++ would be correct, okay? Because we do not perform statement 1 if P is false. But since it is not if and only if, it only says if P, we perform statement 1, it never really spells out what we should do when P is false. So under the interpretation of implication, as we have shown a little bit earlier, this one, because of the word if, instead of if and only if, or IFF, statement 1 can still run when P is not true, because the statement never really specifies what to do when P is false. If you're not getting this, it's okay. If you're getting slightly confused, then you're starting to understand the concept behind all of this. If you're truly understanding all of this, then you can argue with Professor Fox and say, I think that keyword if is not correct. Because it never says what we should do when the condition is false. It should have been if and only if. Okay, are we doing okay so far with this? Yes? Okay. So shall we move on? We got about 8 minutes or so. So are we feeling comfortable with all the operators? Yep, okay, all right. So we can kind of... So the next topic is here, okay, basic set theory. How many people have some exposure to set theory from high school? Okay, we got a few people, okay, but that's okay. We'll talk about the symbols, we'll talk about the concepts in this class, okay. Wait, this is the same thing? Oh, right there. It's on a different tab, right? Okay, so basic set theory. So basically what a set is a container. You can kind of look at it as a folder, okay? So a set is kind of like a folder. It can be empty. So there is such a thing called an empty set, okay? An empty set is a set where there's nothing inside, okay? If something is inside a set, that something that is contained inside a set is called an element inside a set. Is that okay? So an element is the contained item, and then the set is the containing thing. Are we good so far? Okay. And if you want to enumerate what is inside a set, this is the notation. So in this particular example, uppercase T is the symbol representing a set. We use curly braces, okay? So do not use the brackets, do not use the angle brackets, do not use parentheses. We have to use braces in order to enclose a list of elements inside a set. So in this particular case, I'm spelling out what are the elements inside the set T. So in this case, we have 12 as an integer, 5 as an integer, 2.2 as a rational number, 7 as an integer, -1 as an integer, and 10 as an integer. We can also count, right? We can say that it has 1, 2, 3, 4, 5, 6. It has got 6 elements inside the set. Are we good so far? What is the purpose of T? I don't know. Okay, I never specified a purpose of this particular set. But when I refer to T in this case, then I can say, yep, we know certain things are in it and certain things are not in it. Okay, so are we okay with this particular representation? How we can enumerate items inside a particular set? Are we good so far? So the important point of this is T is the set, and you have to use curly braces to enclose the list of elements that is inside the set T in this case. Okay, are we good so far? All right. So using this as an example, now we can try to introduce a new operator. This operator that looks a little bit like uppercase E but not quite is called element of. Okay, whatever is to the left is checked against whatever is to the right to see if the thing on the left is actually an element of the set that is on the right hand side. Are we good so far? So what I'm highlighting here, or where the blinky cursor is really a question. It is not an affirmation. It is not putting something into T, but instead it is a question. It's a question asking, is 2.2 an element of T? That is what it's asking. So the result of this operator is Boolean. It's either true, yes, 2.2 is an element of T, or false. It is not the case that 2.2 is an element of T. Are we good so far? So using this definition of T, this expression evaluates to true. That is correct. Because we know that 2.2 is in fact an element of T as it is defined a little bit before. Are we good so far with the element of symbol? Okay. So on the other hand, okay, let's evaluate this as an expression. 23 is an element of T. It is false. It is not the case. Are we good so far with how we use the operator element of? Okay, very good. So we look at C++. Okay, how would you implement? So this is food for thought, which means it is a question. I want you guys to think about it a little bit. And then later on in the semester, we might actually have some homework assignments that will require you to write a program in C or some other languages to implement the concept of a set. So in this case, I'm just asking you, okay, think about this. How would you implement the concept of a set in C or C++? Now, yeah, go ahead. Well, there are many ways to do it. Now, if you read the notes a little bit earlier, how you list the elements in a set is irrelevant. There's no ordering. Okay, ordering is not important when you look at elements in a set. So in an array, we kind of do the job. You just kind of have to ignore the ordering of items inside an array. That can do it. How many people have taken CISP440? It's a co-requisite, but some people have taken it. Okay. Did you guys study the template classes? Did you study the template class set? Oh, okay. It's not in 430?
No, in Fox's class you do templates.
Okay. Well, because the reason I ask is, having set as a basic type allows you to build more complex data structures on top of that. So it is a tool, it's basically a more elemental tool from which you can build larger things once you have the representation of a set. Okay? Now, what if I tell you the only thing you need to represent in the set are integers? And more importantly, I only give you the range of 0 to 31. Okay? All I need to do is to know whether the numbers 0 all the way up to 31, each individual one, is in a set or not. How would you implement that? How many bits is in an integer?
32 usually.
32 or 64, depending on your architecture. But in most cases, we have at least 32 bits in an integer, right? Are those bits dependent on each other? In other words, does this bit always, is the same as the other one? Or if this one is a 1, that one has to be a 1. Or if this one is a 0, that one has to be a 0. No, they're all independent, right? So that means just a normal integer type. Now, signed or unsigned does not even matter, okay? So a normal integer in C++ or regular C is actually a very efficient mechanism to represent a set if all you need to do is to represent whether 0 up to 31 is in a set or not. Because 0 is represented by bit 0. If bit 0 is a 1, that means 0 is an element of the set. 1 corresponds to bit 1. 2 corresponds to bit 2. 3 corresponds to bit 3. So each bit inside an integer is now representing the presence or the absence of the corresponding value of the corresponding integer. Okay? So we'll talk about this some other time as well, but I just want you to kind of associate the concept of a set with something that you have done already, something that you already know. Okay? So read ahead of me, okay? Because we have a long period of time before we meet again. So read ahead of me, and if you run out of stuff in this slide, read the next link. Yep. Oh, okay. So, okay, thank you. I'll think about that. Thank you.
I just want to give you a quick heads up. My wife's going to have a baby probably this week.
Well,